Phil. Appreciate it. Thanks, everyone, for joining us. Thank you for attending a Mandiant talk today. I know there was no other choice to go and see. So happens that they paired us up so we could just take over the room together. But in any event, again, Matt, Jacob, happy to be here. Super excited to get with this small format, too. Just want to start and take a second. I'm sure everyone hopefully got to attend our event before lunch. We're dedicating this presentation to Ken. A lot of some of the research and presentations that we're doing this year, we are dedicating to Ken's memory, and his family is here. And if anyone gets a chance, please go talk to them. They are absolutely awesome and really cool to talk to. So that being said, there's a really quick agenda. This is the X Big Four, and Jacob and I, we feel like we need to lay out an agenda to tell you what we're going to talk about as opposed to just talking about it. So we're just going to fly past this part. First, we're going to get into who we are. While Jacob learns how a microphone works, I'm going to tell you right now that this next section is by far the most boring part of the presentation. If you have insomnia, just read this slide. I will cure it for you in about 2 seconds. My name is Matt again. As Phil so eloquently put, I work at Mandiant, which is now a FireEye company, which owns a bunch of other things as well. In my previous life, I worked with a lot of crazy chefs and then 2 of the Big Four.
And I also worked for the same 2 of the Big Four, so we don't quite have them covered between us. And also currently working at Mandiant now.
And then if you wanted to get a hold of us outside of this presentation or this conference, I tweet and blog, and Jacob does the same as well from the blog in front. So feel free to come and find us. If you can find the age of Jacob post, it's really good stuff. He just posted it a long time ago, and I still reference it. So go read it. It's really stuff. All right, so first we have to talk about why we care so much about SQL. There are amazing artifacts inside of all these operating systems that everyone here does a lot of research, spends a lot of time looking at. And we're like the 2 guys out on the side, like, nah, you need to be looking at the database. That's where you need to be. That's where everything is. Why do we care? Because guess who else really cares? Any guesses? Who else really cares about your database? Your attackers. They really care about what's inside of the database. Quite frankly, that's probably why you're being targeted in the first place. And as investigators, as incident responders, as what make-believe detectives, which we like to think we are, we also paint pictures as well. We describe narratives. We tell a story of what happened during a breach, during an incident. And we tell these whether it's to our clients, to our bosses, to our CISOs, to whomever, to regulators, lawyers. We have to paint the most complete picture we possibly can. And the number of times I've seen a report or I've seen an incident where it says, yep, someone came in, they attacked us via this really cool exploit. Then they did all this really awesome SQL injection. Look at them getting smarter as the minutes go on. Look at this change. Look at this adaptation. Look at them figuring out our environment. And then the data walked out the door. Boom. All right. Awesome. Done. There's a giant missing piece there in that statement. What the heck left? What walked out the door? 10 gigs of data were stolen. Means nothing to me if you can't quantify those 10 gigs. We can talk about other avenues. Was it encrypted? Was it encrypted by us? Was it encrypted by them? But where did 10 gigs come from? Flip side of that is SQL analysis can also help you answer questions in a reverse way as well. 10 gigs walked out the door. The SQL database is 10 megs in size. All right, we need to go somewhere else if we haven't yet understood it. So we care a lot about SQL. And believe it or not, we've actually had quite a few cases in the past year, I'd say. Actually, Jacob and I hit our year at Mandiant yesterday, so we're super happy. Our anniversary, if y'all would just celebrate for us. But in any event, we've had a few cases in the past year that have actually relied on database forensics to answer that question. What walked out the door, what was stolen? Anything to add?
Yeah, just there is another party that will care very much about what was in that database and what might have walked out the door, and that's the lawyers you have to interact with.
Yeah. Anyone here ever interacted with a lawyer?
Yeah.
Anyone here a lawyer?
Oh, wait. Oh.
All right. we gotta scale back some of the comments.
All right.
Then.
I'm going to trim that.
Fair enough. Okay.
But each and every bit that we can account for, they're going to want to know. Absolutely.
Anyone else think of one other party that we maybe didn't talk about so much that is really interested in this as well? If you're a public company, you have to answer to one of these bodies. Regulators. Yep. Government reports are not fun to file, especially with a bunch of question marks. Because guess what? You're doing more work. And guess what happens when you run out of that hour cap you had as well and you didn't answer all the questions you were supposed to answer? Guess who's eating the money? Not the client. Let's put it that way. So not only did we care about this little part of forensics that not too many people seem to really care about, and it's odd I'm saying this with Kevin Fowler in the room who actually wrote the book on DB forensics, so this is like the one crowd where there is someone who cares about it as much as we do. But that being said, we also took the challenge harder and we said, you know what? In previous talks and in some of our analysis, we've talked a lot about putting an analyst inside of SQL to pull back artifacts and analyze them that way. Is anyone in here a database admin? Is your first role a database admin? Let's put it that way.
Or was it in a previous life even.
Or was it previously?
I'll take that.
Yeah, in some way, shape, or form, Maybe you were a database admin. Is that your current role? Exactly. So why, as an investigator, how many roles do we already wear now on the phone? I think this week I've been an incident responder, a network engineer, or a mediation expert, a regulation expert. By the way, the expert is that little quote thing around it. And we have to answer questions all the time that are not really our field of expertise. To take an incident responder and say, all right, for this little bit of analysis, I need you to be a database admin, doesn't make sense. You can also damage volatile artifacts. The database is extremely finicky. It lives primarily in memory. We're going to talk about that in a little bit as well. Requires you to know SQL or DB admin. Who here has ever downloaded a script that you needed to use for a tool and it was broken and you went to fix it and you were like, I don't understand this language. I don't know how to fix this, so I'll submit a bug report. You don't have time for all that. How many people downloaded a script and found it's just one line of Perl? Oh gosh. I'll just write Eric Zimmerman, if you're around, if you're available, help me out here real quick. That being said, so why are we asking our analysts to, when the moment strikes, know SQL and know it well enough to walk a client through responding to an incident? We're asked to wear many hats. DBA is normally not one of them. And then last but most importantly as well, databases, they're not designed to be forensic artifacts. They're designed to take data, do things with it, sort it, optimize it, index it, make it readily available, and get it out of the door. It was put in there for a reason. It is also being utilized in some reason as well. So why are we trying to make something that's not a forensic artifact a forensic artifact? The last little line is the most important one too. Databases beat the crap out of memory. So we thought, let's take away the database. Put an analyst in a situation they're comfortable with being in, and let the analyst use tools they're already familiar with. Why? Why did we want to do this? Because it lets you add this artifact and this type of artifact to your workflow instead of having to build a new workflow around database forensics. No one has to become an SQL guru. I'll tell you, Jacob and I have learned a lot of SQL guru. Jacob like 10 times more than me, which shows the level of dedication. But the value is provided to the client a lot faster when you come off as an incident responder who is speaking about artifacts you understand or speaking about a process you understand, as opposed to, all right, here's the script, let's try it, let's see what happens. Or the worst part, and I've seen this happen a couple times, luckily not on our team, but I've seen this, hey, I wrote a script to do XYZ, can you have your admin look at it and make sure it's okay, and then run it? You very quickly lose the expert opinion after issuing that email afterwards, because they're like, oh my gosh, this guy doesn't even know what he's talking about, and he's asking us to install things, pull back data, modify our environment. He's also asking us to respond to an incident, which we're not doing a very good job at.
And it really helps to work with the client's DBA in a lot of these cases, because nobody's going to know that database better than them, other than maybe the attacker, depending on how long they've been there.
Anyone here ever learned anything about their network from an attack? Yeah. It's okay, you can raise your hand. We know it's happened.
Yeah. So yeah, work with those guys. They know their stuff inside and out. They know the queries that you're trying to run. And going back to the volatility point, I mean, every time you run one of these scripts, let's say you hacked something together and it doesn't work the way you want, that's going to be pushing something else out the back end and overriding some data you probably wanted to get at.
Exactly. We don't normally test in production environments, so why are we asking our client to do the same? So what does that leave us with if we take away the database? It leaves us with a few different things. Some of these are going to sound really familiar. Logs. Log analysis, not foreign to most of the people in the room. If you haven't done log analysis yet, let me know. I've got some great sample data sets we can play around with. Logs, when we say external logs, we talk about logs that you don't need SQL Server to open, which, believe it or not, if you've ever done any sort of Microsoft analysis, to say I'm going to give you a Microsoft log and you can open it in a text editor, it should start blowing your mind a little bit, because most of the time you have to download something. Well, sorry, let me back up. Register for TechNet, download something, figure out how it installs, realize you don't know what .NET really is, realize you have the wrong version of .NET, and then by the time you get to the artifact, it's kind of like, oh, hey, the attacker's already gone. Thank you for taking your time to figure this out. We can also copy off SQL data and log files. Jacob's got a little bit of advice kind of about how this works.
Yeah, it's very quick and dirty. You just grab the MDF, which is the actual database, the LDF, which is the associated transaction log, and you can spin up a VM. You install SQL Management Studio. It's a whole process, but then you can load the files in. You can actually do your own queries against that data with some caveats.
Exactly, yeah. And that's a super helpful situation to be in, because you can say, I know the attackers ran these 20 queries. Let me run these 20 queries against the same data set in a non-log, non-production, completely safe, blocked off environment and see what they would have pulled back. Right? It helps you, and again, it's a negative answer to a question. This database has 50 million credit cards in it. Well, I did exactly what the attacker did, and I only got 200,000.
And I think that did help on a case recently.
Yeah, exactly. We did actually take a massive database and size it back down. And then we've got kind of the best artifact as well. We save the best for last, memory. Everyone loves memory. Why focus on memory? Because Microsoft wants it. They will use it and they will abuse it. SQL Server 2014 actually came out with in-memory OLTP, in-memory optimization. There are database admins whose entire job, anyone know what the #1 goal of a database admin is? Keep the database up and running. Yeah. They will take a look at your please shut down and make a forensic image for me request and just throw it away, because their job is uptime. Their job is to keep the data available. There are database admins who are experts at pushing as much as they can into memory. They're optimizing records, they're optimizing tables, they're optimizing entire DBs. It also means that with us pushing more data to SQL, it makes memory more of a valuable artifact for us. Now, granted, that being said, we've got a screenshot of 2014 up here. Anyone here still running SQL 2005? It's okay, you can say. We won't hold it against you for...
Or even earlier.
Aside from testing. But 2008 seems to be the one we run into the most. So from a forensic point of view, again, there's all these awesome Windows 10 artifacts. The last enterprise scale investigation I've done was Windows 7. We had a couple Windows 10, and it was great to flex our muscles with some of these things, but some of the older models or older versions are what we're still seeing in the environment, so we have to account for those as well. Last but not least, we like memory because we're comfortable with memory acquisitions. We're comfortable with memory analysis. It gives us a quick place to pivot. Gives us a very, very quick way to say, this memory artifact gave me blah, and I know how to translate that into XYZ, as opposed to, I did the database forensics, and this is what I have, now I'll move on to something else. We need a way for this to become part of the larger picture, not a siloed artifact. So let's talk about those other artifacts.
Yeah. We've got logs. We've got lots of logs. You've got your basic Windows event logs, SQL Server every time the server comes up or goes down, every time somebody logs in. These are all recorded in your standard event logs. That's always a nice place to start. But then we've also got generated logs by SQL Server itself. Specifically, these are the trace and error logs, which are both useful in different situations. The trace logs are great because they can give you actual queries that were run against the database. You can find login times, users that were logged in, a client they might have been using. That was helpful on an engagement we had recently where there was this mysterious application connecting to the SQL Server that none of the DB admins knew about, none of the business users knew about.
Boom, smoking gun.
And yeah, lo and behold, that's part of the smoking gun. And then there were also these error logs, which, contrary to their name, are not actually error logs. So they are, but they also include login times. And
yeah, it's odd. Error logs, they're plain text.
They're plain text.
The best part.
Yeah.
You can open them with a normal text editor. You can grep set and awk a Microsoft log. That needs to be written down in the history books, I think. It does track other things, though, not just errors. Startup, shut down, log in, log out. Starting to seem like error log was a misnomer for what is actually stored in here. But this is from the same place that gave us bad coffee and dead beef. Let's not forget that now. They can be removed and examined on a separate analysis system. Error logs, it's also important to note the state codes as well. What is this telling me? What are my state codes meaning? Is it an invalid login? Is it an incorrect password? Is it an incorrect username? Is it an incorrect Windows login? SQL can have its own authentication mechanism or it can tie right in with Active Directory. Depends on what level of access.
A bunch of brute force against the SA account coming in.
Yep.
Anything.
SA account is where you want to be, by the way, if you are a red teamer in the room.
Yeah.
Other logs we've got as well that are super important. Our Windows event logs are going to give us a lot as well. As anyone here knows, Vista Plus, we're going to have application specific. Our web logs is going to give us the external access route to our DB. If you have a web server that can access your database via some way, shape, or form, I don't care how many layers of segregation you have between the two, that entire path should be logged. Yeah. Because just when you think you've got it all secured, someone out there drops some 0-day and they figured out something supremely unique that you've never seen before, and boom, your data walks out the door. And you say, oh no, I secured it, I just didn't log it. That's when we get called, and it's a very interesting discussion. Firewall logs. Anyone here know the default port for SQL Server? No one? Hey, there we go. Boom. All right, one winner. I wish I had something to give out. I'm sorry. Thank you for answering, though. That was fantastic. Know your ports, know your logs. All right? Should 1433 ever be connecting outbound, ever, over any sort of connection whatsoever? If in your organization the answer is yes, highly figure out why that is. If not, and you see it, figure out why that is. 1433 on the firewall is interesting. Do we have suspected data theft? Know what your logs can tell you. Aggregated byte counts. What can I get out of my logs? I'm not saying log every single SQL server query that was ever issued to the server, but log that route around it. Find ways to get and extract data from that. And then more importantly as well, network traffic. This goes back again, know your ports, know your IPs. Right? What should be accessing it versus what is accessing it.
This is probably how you know if 10 gigs walked out the door or not.
Exactly.
Net flow in the first place.
And that's not a fun question to have to answer with a question mark either, or a shrugged shoulder, or an I don't know. How much data walked out the door? We didn't have logging in place. Sorry, have no way of telling you that whatsoever. Now let's look at the other supreme artifact as well, memory. Why is memory so essential? Well, there's a couple of tidbits here about some sizes of databases. Now, we're not, number one, displaying these as clients, and number two, we're not displaying them as potential targets. We're just trying to give you some sort of premise as to how large these data sets get. The Panoramic Survey Telescope and Rapid Response System, or the PAN-STARS, they have about a 1.1 petabyte database. NASDAQ, company we can all agree is probably somewhat important to the financial industry, adds 500 terabytes of data to its SQL instance every single year. And the funny thing is we actually gave this talk, or we gave a version of this talk and presented this statistic, I think in November last year, and a dude from NASDAQ walked up and was like, bro, you're so under. It's way much more than 500 terabytes a year. And I was like, cool, you just added more validity to our discussion, but we're not going to change the slide because then I get this story out of it. Let's look at another way too. 500 terabytes a year. Anyone here want to image that database server, distributed it or not? Anyone want to image that logical volume? I didn't think so. What's going to be smaller than the size of that logical volume? The memory, just by sheer the way things work these days. Sometimes 128 gigs is going to be better than 6 terabytes for me. Because as an analyst, by the time I could probably run some commands against that memory dump, I'm still a quarter of the way through imaging. So what can we get out of memory? What can we dig? Jacob, why don't you tell us about SQL Data Page?
Yeah, it's really fantastic. SQL made it nice and easy. Everything is just an 8K chunk. So every 8K, you've got a SQL data page, like we've got here. And they have a very defined structure, of course. It's a relational database. Yeah. So these are things we can carve for in memory.
And it wouldn't be a technical presentation if we didn't have a hex screenshot in there. So we've got that part taken care of. But this is how it looks. Thank you. Thank you. So this is, y'all can, great, that's it, we're done. That being said, this is actually the hex representation and the SQL representation. So these exist inside of memory. We can carve them out. We can dig them. It's the storage format. As Jacob said, it's 8K in length. We've got a header, which is 96 bytes in length. And then we've got data and pointers, which is 892 minus 96. Pointer structure is stored in reverse, AKA the first record is stored last. Hint, hint, hint. Any hint as to what a footer might be? Anyone think? If they're stored in reverse, we know that our data records start at byte 96. And if the first record is stored last, our footer then becomes pointer to the 96th byte, because that's where our data starts. Looks a little bit like this in the header. We've got our header versions, our type flag bits, our level and our flag bits, and there's a whole other kind of list of strings that go down there that define what this data page is. Is it a simple data page 1 of 100,000? Is it a global allocation map? Is it an extension of the global allocation map? What is this actually telling us about our data that's inside? The footer, we kind of talked about this already. It's the start of the first record. It's a hex representation of 96. Which gets us down to the very bottom. You can see kind of the last 2 digits there is our converted endian format of 96. So that's kind of our start. So now we've got a way to carve for these. Let's also, we took this and we actually threw Scalpel against the memory image really quick, and we were actually able to carve out the data pages. But what does this actually mean to us? Oh, congratulations, you found an 8K page, a series of 8K pages stored in a memory image. Yeah. What does this mean to us? Closer we are to the breach, the more relevant the data in memory is going to be. Does my database contain PHI, PII, PCI, something else offensive that we may not have wanted our attackers to get a hold of, something that I need to be aware of? And then also, more importantly, did the attacker create a new table, make a change that hasn't been committed yet, run malicious commands? We're going to be able to pull a lot of this out. What else? Anyone here ever interacted with an SQL server? What did you use? Oh, not this guy. What did you use, Jacob?
I use SQL Management Studio.
SQL Management Studio. Guess what else is stored in memory? You know that little text box in SQL Management Studio where you type in all your commands and it has no respect whatsoever for white spaces? I bet the creators of Python hate SQL Management Studio for that exact reason. It has no respect to white space, but guess what? That little text box is stored in memory. That's something we can carve and dump. And you may think to yourself, nah, all the attackers are super advanced. They use all these custom command line tools, and they issue very, very strict scripts to query your SQL database. And Jacob's going to call you and say, no, they don't.
Yeah.
Not at all. If it's there and it works, and I can log into your domain controller every single day with shared credentials and use SQL Server Management Studio and not have to worry about getting caught or having my logs detected, guess what I'm going to use on a daily basis, and guess what the attackers are going to do? So you may think to yourself, this seems really simple. These are all basic database admin tools. Exactly the reason why we need to know what an attacker looks for. And then last but not least, the plan cache. Tell us a little bit about the plan cache.
Yeah, it's a lovely SQL artifact. So every time you go to write a query and you submit it to the SQL Server, it figures out what to do with that query, like on an actual technical level. And it stores it in what it calls the plan cache, which is where it deciphers all of these planned steps for execution of the query. So every time you've got a query, it's run, it's stored. There's this disgusting looking hex handle. I think we have a screenshot of it somewhere in here.
Look at that.
Yeah, right there. This beautiful, beautiful hex just hanging out. But you can
Screenshot number
actually
2.
take that handle and you can feed it back into another query in the plan cache, and you get something a little bit easier to read.
Looks a little bit like that.
Yeah.
So we can take that and convert it. These are all pointers. Guess where all of these pointers, A point to and B sit? Lovely memory. Thank you very much, SQL Server. Push as much as you want into memory, because then we can go in and carve it and find it.
Which is really nice, because if you grab the whole plan cache, you just look for anything that says select star. It's
Exactly.
probably
yeah.
a bad
So
guess.
what's the first, I mean, Jacob kind of alluded to it already, but if anyone who's done an SQL investigation, what's the first thing an attacker do? What do you first do when you walk into a room that's completely dark? You look for a light switch. Yeah. What is in this database? Guess what query your database admins usually aren't issuing if you've got an established company? The database admin who knows the database like the back of their hand, it's their job, it's their baby, it's what they do, what they take care of, and all of a sudden you see 15 select stars in a row issued by the database admin at, I don't know, 3 a.m. Database admin works 9 to 5, does not alter from those hours whatsoever.
Has a data dictionary.
Has a data dictionary.
Doesn't need it.
Knows how to reference his database. He is not issuing 15 select star commands in a row. He already knows what's inside of that database. So there's a lot of great value about attackers' actions, attackers' motivations, and the scary part is when you go from select star to now select targeted artifact. I lost my
Oh, clicker's off the rails.
clicker broke. Can we go to the next slide? Sorry, I'm known to
Were you trying to use the laser?
break batteries. No, actually, there's nothing. What's that? No. Sorry, give us just a moment. Anyways, we can actually move on. There we go, perfect. Next slide, and then we'll just wrap it up. So we've got a couple minutes left. But anyways, to kind of wrap things up and kind of put a bow on this nice little database analysis. Can we go one more? Oh, there we go. Okay, perfect. All right, so again, we talked a little bit about forensics teams, processes, and workflows. Determine if the team needs to change based on an artifact, or if the artifact can change based on your process. Do we actually need to go to a database? There's a quick caveat to this. Never, ever, ever change an artifact. Kind of self-answers the first question.
Yeah, I mean, every time if you've got a former database admin on your team, and hey, they can pimp out some SQL queries, that's great. But every time they run one of those queries to pull back all this interesting information, it's going to push something else out the bottom. So you just need to keep in mind the volatility of all these things and imagine, okay, every time I run one of these interesting queries, it returns me interesting results. I'm going to be losing something else that might have been interesting as well.
Yeah. To Jacob's point about volatility, let's go to non-database SQL artifacts. They can provide us just as much, if sometimes not more, value for the team. Remember as well, we're talking a lot about volatility. If you ever are, if anyone here is on a red team and you're attacking an SQL database, go find what the flush commands are and run them all at the end of your pen test.
You don't have to do that. You can just Google it. It's right there.
You could do that
it's
too.
A one-liner.
Stack Overflow probably has some great flush commands on it. You can pull them down from there. And last but not least, as a forensic investigator, learn what the artifacts are, learn how to parse them, learn how to interact with them, and learn how to interpret them. Getting 10 gigs of error logs from an SQL server is awesome. It means nothing if you have no idea what type of data is going to be inside, or if you, God forbid, ask for the wrong thing. Think about certain points. Do error logs contain only errors in them? This is another great discussion you can have with your clients as well. Give me the error logs. Why? They're errors. They've actually got more inside. That's how you have phone calls where you walk away and you hang up and the client goes, we hired the right people, which I think at the end of the day is really the goal for what's going on. So that being said, oh, works, awesome, okay. That being said, thank you all very much. I think we've got a couple minutes for questions. Well, perfect. If there are any questions, happy to take them. If not, thank you all very much in choosing this Mandiant presentation in your afternoon.
Any?